Alright guys, here's your practice test video. You can skip around as much as you need to, watch what you need to, as many times as you need to, but let's get through this thing. Make sure you're ready for Friday. So the first one says, which of the following involve independent samples, which means they're not paired together. Part A, to test effectiveness is an Atkins diet. 36 randomly selected subjects weighed before the diet and 6 months after. So it's the same people, so they are paired. So because that's their before and after weight, so those are not independent. Part B, determine whether smoking affects memory. 50 selected smokers are given a test. Word recall and 50 non-smokers. They are not paired in any way, so that's independent. Part C, annual incomes are obtained from a random sample of 1,200 residents of Alaska and another random sample of 1,200 from Hawaii. They are not paired anyway, so they are both independent, B and C. Number 2, this should seem familiar to you. Assume you want to use a 0.01 significance level to test the claim that the mean number of words spoken by men per day is less than that of women. What confidence level should be used if you want to test the claim by using a confidence interval? Because it's a one-tail test and we're going 0.01. Remember, 0.01 really represents 1%. Double it to 2%. What's left? 98% confidence level. Number 3, basically says find everything. It's got an A and a B, test all the methods. So take your calculator, and I'm going to go ahead and do part A here. The hole in the ha, obviously first. The problem says if we use the body temperatures from a study done on 8 a.m. on day 2 of a study, we get the stats below. Use these data with a 0.01 sig level, test the claim that men have a higher mean than women. So what we're going to do first is say our ho is that they are equal, and the men comes first here in the chart. So we're going to say that the men have a higher mean temp, so M1, mu1 greater than mu2. All right, so my calculator, I'm going to stat test and looking for 2 sample t-test, which is number 4. I punched in all the stuff that they gave me there in the problem for the X1, S1. Just make sure you put stuff in the right spot. Go down where it says the ha is greater than M1 is greater, sorry, mu1 is greater than mu2. Do not just check no for pooled. Go to calculate, hit calculate, and here's what I'm getting. My t value, my test stat is 0.859. My p value is 0.203. And then I need to go find my crit value so I can compare that to my test stat to my critical value. So I'm going second vars, number 4, 0.01 is my sig level. Degrees of freedom, look at the smallest n. In this case, it's 11. So my degrees of freedom is 10. Go to paste. I'm getting negative 2.76. In this case, it'd be positive because it's a right tail. 2.76. All right. So because the t that will not fall in my region, my rejection zone, plus the p-value is larger than the 0.01, you would fail to reject HO. Fail to reject HO. And I'm going to wait for the sentence for part B and see if I get the same answer. I'm assuming I will. It's the confidence interval, so I'm going to go back to stat, test, and go down to number 0, which says 2 sample t interval. I already got the numbers in there. You got to change your C level. C level is going to be 0.98. If I can get there we go. No pooled. Go to calculate, hit enter, and this is my confidence interval that I'm getting. I'm getting negative 0.5117 less than mu1 minus mu2 and 0.99168. Now because 0 is in there, and because that's what the ho is, I'm also going to fail to reject HO, fail to reject the null again. The claim was actually the ha, and since I'm failing to reject, what we would say is there is not sufficient evidence to support the claim. That would be the sentence. There is not sufficient evidence to support the claim. Number 4, another one just like that one. Let's read the problem first. It's full IQ scores for random sample of subjects with low lead levels in their blood, another random sample of subjects with high levels in their blood. The stats are summarized below. Use a 0.05 sig level to test the claim that the mean IQ scores of people with low lead is higher than the mean IQ score with high lead. So my ho and my ha is going to be what it always is, mu1 equals mu2. The ha, here we go again. It says the low lead levels is higher than high. So low levels M1 is the first one up here, greater than mu2. All right, next, let's punch the numbers in the calculator again. Okay, once you get them in there, same spot, 2 sample t-test, number 4, make sure you choose greater than, and no pooled, go to calculate, hit enter. Here's what I got in my t. My test statistic is 2.28. P-value is 0.013, which is important. That 3 could be important. And I need to find my crib value. Remember to find your crib value. You're going to second bars, inverse t, 0.05 this time. Degrees of freedom, be careful here, is 20. Paste, boom. I'm getting this from my crib value, 1.72. My test stat is definitely past 1.72, and my p-value is definitely lower than 0.05. So in this case, we would reject HO, reject your null. Before I write the sentence, I'm going to do the confidence interval again, which is part B. So go back to stat, test, go all the way down to 0, which is the confidence interval, t interval, hit enter. Numbers are already there. Change your degrees of look at your sea level though. This time my sea level is going to be 0.90, so change it to 0.90. No pooled. Calculate. I'm getting this right here. I'm getting 1.59 is less than this. Oops. Minus mu2, which is less than 10.364. It looks like could be higher. Not trusting my eyes right now, but anyway. There's no 0 in there. Because there's no 0, we definitely reject HO, reject the null. Okay, so because we're rejecting HO, our sentence would be, there is sufficient evidence to support the claim. Y'all are great at sentences by now. Not too worried about you there. Let's finish this thing up. Number 5, now we're going opposite. Number 5 says, when working with 2 dependent sample means, match pairs, which of the following are not true? Okay, they're not true. That's the key. They are not true. The requirement of an SRS is satisfied if we have a voluntary. That's not true. You cannot do a voluntary response and get an SRS. That's not true. Part B, if we have 5 matched pairs, there's a loose requirement that the 5 differences appear to be, no, you got to have more than 30, greater than 30. That is, that's not true. Part C, if we want to use a confidence interval to test a claim that the mean of the differences is greater than 0 with a 0.05 sig level, the confidence interval should have a level of 90%. That is true. Part D, the methods we use with matched pairs apply if we have 50 heights of women from Texas and 50. No, they have to be matched. Those women are not matched together. So that's not true. I keep wanting to circle it because it is true, but we're doing not true. That's kind of confusing. Part E, if we have more than 10 matched pairs of data, we can consider the sample to be large and there's no need to check normality. That is not true. You have to have more than 30. All right, if you're looking at your test, this is not the problem you see for number 6, but this is what we're substituting, okay? I thought we were going to get to something we did not get to, so this is going to take the place of number 6. I would have just probably canceled out number 6, but there's only 8 problems, so we really need number 6. We just do. So here we go, and I will replace the one on your test tomorrow with something very similar to this, so you'll know what's going on. It says, doesn't matter, the heights of U.S. presidents and their main opponents in the presidential campaigns is what what the table represents down here. Only using a random sample of those. Says use the sample data down here in this table with a 0.05 sig level to test the claim that the population of heights for presidents and their main opponents, the difference have a mean greater than 0, which means so the presidents are taller than what their opponents are, which a lot of people think is always true. So our whole, so what we did yesterday, is going to be the mean of the differences is 0. Our ha then, because they're saying the presidents are taller than their opponents, that's what the claim is, we would say that it is greater than 0. So that's your ho and your ha. Well, we had to figure out, we had to work through the test stat. If you really look at the table here carefully, there's the heights of the presidents, those are the heights of their opponents, and this line down here at the bottom are all the differences. Okay, that's a bit of, so I've already found the differences there at the bottom of the table. All right, guys, and the formula for our test stat is going to be the mean of the differences minus mu d, which you don't really need that because that's going to be 0. Look at our hoe, over the standard deviation of the differences over the square root of n. That's the way you find our test stat. All right, so the best way to do this is I basically took that bottom row right here, all right, which is the differences, and I plugged them in my L1 on my calculator, and then I'm going to go to one var stats, and I'm looking for the mean. So I'm looking for x bar. Even though I'm loading d bar, when I punch those in, I'm looking for the mean of the differences, the x bar. And what I found when I did this, I got 33.2. And I already told you that's 0. That's always going to be 0. You don't have to put that if you don't want to. Also, when I did one var stats, it also tells you what the standard deviation of the differences is. It's 11.4, and we have 5 precedents, so it's going to be over the square root of 5. All right, that's how you do the test stat. And when you work that out, and move this up a little bit, as you work that out, the test stat is going to be 6.28. I write that mess of decimal up, sorry. 0.628, my eyes, I'm sorry about that. That's the test stat, 0.628. Now, obviously, we need to compare that to the critical value. So I'm going to do that right now. All right, just punch that in, and I go to inverse t because it's still a t distribution. Put a 0.05 sig level. Degrees of freedom is 4 because there's only 5 in the sample. Hit paste, and I'm getting this right here for my critical value. I got 2.132. So there's my critical value. Obviously, this number right here is not past positive 2.132, which means I have to fail to reject the null. I did forget to write which one was the claim. The claim was that the precedents are taller, so that's the claim. And if I'm going to fail to reject HO, I would have to say, obviously, that there is not sufficient evidence to support the claim that the main differences in the precedent's heights versus their opponents is greater. Right, so that's all I need to do there. All right, one thing I haven't said about this test yet is that everything in this test is a mean. You know, last week we did all proportions. Test scores were great, so I thought we'd do it again this week with all means. So we started with independent pairs, then we did one little match pairs problem. Now we're going back to review with just means also. Number 7 says this is below the ages of randomly selected race car drivers. Use a 0.05 sig level to test the claim that the mean ages of all race car drivers are greater than 30. So I'm going to let you do what we did last week. If it's a review problem, I want you to write your ho and your ha, and you can just go p-value only if you want to. So you got 3 methods. You can do crit value, you can do p-value, or you can do confidence interval. I think the p-value is the quickest and the shortest, so that's how I'm going to do it here. It's your choice what you do after that. So first thing I did, ho and ha. It says test the claim that mean ages is greater than 30. So for the ho, we would say that the mean or the mu equals 30. And then for the ha, we would say it is greater than 30. And that's our claim. All right, now you have to take all those numbers, punch them into L1, which I've already done. So now I'm going to go to stat, test. This is one sample t-test. All right, so that's just t-test. Number 2, t-test. Click data instead of stats. It asks you what your ho is, which is 30. Reasoning list L1, and we're doing a greater than the null. Go to calculate, and it gives you all this stuff. It gives you this, and this is okay. This is the test stat. It gives you this. You should see this, even though I'm not going to use it. It's like 1.82. This is what I want as my p-value, which is 0.045. Even though it's barely less than that, it is less than 0.05. So I would reject the null, which means your sentence would say there is sufficient evidence to support the claim. Okay, so on that one, it's one sample, and if it's because it's one sample, it's just t-test. It is one. There's not something on your calculator when you go to stat test. It says one sample t-test. It just says t-test. Okay, so that's where you go. Let's get this last one here. Number 8, the weights of discarded plastic from a sample of households has summary stats. There they are. That's the sample size. Sorry. There's a sample size. That should say X bar, and there's a standard deviation. Use a 0.05 sig level to test the claim that the mean weight of discarded plastic from the population is greater than 1.8. So that means HO would be that the mu equals 1.800. The Ha, it definitely said is greater than that, so mu is greater than 1.800. Okay, going back to the calc, stat test. It's still one. There's only one sample, so just do number 2, which is t-test. T-test. Go to stats this time because they gave us the stats. The hoe is 1.8, so I'm typing in 1.8 for the hoe. X bar was 1.911, which is your sample mean, by the way, which is quite a bit above the hoe. Standard deviation is 1.065, and the N is 62. And we're thinking it's greater than again. Go to calculate. Here's what I'm seeing. If you're going to do critical value, this is what you need, your test stat, which is 0.82. I think it's 0.82. Yes. I'm going to use p-value. The p-value is 0.208, which is pretty high. And we're using a 0.05 sig level. Because we're using 0.05 sig level, my p-value is definitely bigger than 0.05, which means I'm going to fail to reject HO, fail to reject the null. That was the claim. If I'm not going to reject that, I can't support that. So my sentence would be, there is not sufficient evidence to support the claim. All right, and that's your practice test. Study it one more time sometime this evening. I will be at school tomorrow to give you a test. Hopefully you do great again just like last week. See you then.